Hello everyone, this is Heading. Today's video, we will learn about the truth table for negation, conjunction, and disjunction. Let's see first part. Use the definition of negation, conjunction, and disjunction. Before previous class, we learned the statement, for example, the statement P. If the P is the true statement, I say this is true. The negation not of the statement P, not P, is false. If the statement P is a false statement, not P is a true statement. So here, they use the truth table. So this kind of table we call truth table. They have the simple statement here and list their truth value here. And the first row, they are all the statements. And then the following part are their truth value. Okay, so this shows us the statement P's value, truth value is true. The negation of P is false. Next example, if P is false, so not P is true. Next part, we learn about the conjunction. Usually we say this is and. The definition of conjunction. In this table, you see the truth table. And it shows a conjunction is a true conjunction. The value of this is true only when both simple statements are true. Only when P and Q, they are all true, the conjunction is true. So if PQ has one false, the truth value is false. In the statement, simple statement, if one of them is false, the conjunction is false. Both of them false, the conjunction is false. So memorize that. When you see this, P and Q, in the simple statement PQ, if we have one false statement, maybe it's here or here. So the result of this is false and true. That is false. True and false. That is false. And both false is false. The only one true condition is both P and Q are true. Okay, let's move on to see the example. The first, they list the simple statement. P is, I visited London. Q is, I visited Paris. In the case one, your friend actually visited both cities. If I list the true or false table for this one, so P, Q, I can add another part. So actually visited both cities, that means true, true. The conjunction P and Q should be true. So the conjunction is true. The case two, your friend actually visited London, but did not tell the truth about visiting Paris. That means in the new table, P, Q, P is true because actually visit London, and Q is false the conjunction P and Q is false because one false, the conjunction is false. Next case, this time London was not visited, so P is not true. So, but Paris was in the table PQ. P is true. P is false because was not visited. So London. So P is false. Q is true. The conjunction P and Q is false because we have one false. The result must be false. Next case, your friend visited neither city, both city, these two city. So P is false and Q is false. If two of them are false, that means if I still use this kind of table, P, Q, P, and Q, false, false. So the result, the truth value should be false. Let's see more examples in the table here. Look at this statement, the word statement. This one is a statement, and London is in England. So, and connect two statement. So also, and is a conjunction. That's a sign, symbol of conjunction. Okay, so 3 plus 2 equals 5 is true. And London is in England. That's true. True and true is true. 3 plus 2 is 5 is true. London is in France is false. So the conjunction is false. 3 plus 2 is 6, false. London in England is true. False and true is false. 3 plus 2 is 6. This is false. London is in France. This is false. False and false. This is false. Okay, let's move on to next example. They gave us a symbol expression. So the statements that make up this conjunction are parts. The first part is in the parentheses. The second part is the first part is here. The second part is after the conjunction symbol. The conjunction is true only when both first part and the second part is true. True and true is true. Notice that this part, not P or Q, is not a simple statement. We call not P or Q and not Q the component statements of conjunction. The statements making up a compound statement are called component statements. Let's see disjunction. We use the symbol this. We say that is or. The definition of disjunction. A disjunction is false only when both component statements are false. That means if I have two simple statements, which is P or Q, when they are both false or false, the truth value of this part is false. Otherwise, they are all true. Just like the example that shows the table that shows us true or true is true. True or false is still true. False or true is true. false or false is false. So when the disjunction P or Q, they only they have one true, maybe here, maybe here, maybe P is true or maybe Q is true. The disjunction is always true. It's always true. And the only one false condition is P and Q. They are all false. Okay, let's move on to see the example in the table. 3 plus 2 is 5. Yes, true. London is in England. True. So true or true is true. 3 plus 2 is true. Or London is France. False. True or false is still true. 3 plus 2 is 6. That's false. Or London is in England. That's true. True. Oh, sorry. False or true. That's true. If we have one true in the disjunction, that's true. This part is false. London in France is false. So false or false is false. Let's see more examples. Let P and Q represent the following statement. P is 10 is greater than 4. This is true. Q is 3 is less than 5. This is true. Determine the truth value of each statement. So true and true. That is true. Not P and Q. That is false. Because the opposite value of a true value is false. False and true. That is false. True or false. True or false. Here is a or. That means true here. False or false is false or false is false. Okay, let's move on. Oh, here are the explanations of this question. Next part is construct truth tables. What does the table look like? The table first column or first and second column, maybe you have a line here. Okay, first two columns are the simple statement P and Q. If the question only have, if the question has only two simple statement P, Q, we need to list all the possible truth values for P and Q. For P, Q, two simple statement, we have 4 possible values, possible cases, which is true, 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 false, false, true, false, false. What's the next step? Oh, here, give us the example. Let's use the example to show us how to construct a truth table. For this statement, compound statement, not P and Q, to determine when the statement is true and when the statement is false. First step is to list the simple statement on the top, just like we talked before, P, Q, and list the 4 possible truth values, which is true, 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 false, false, true, false, false. What's the next step? So remember this. We will use it later. So we already listed the simple statement PQ. And the next part, we need to add another new column for the statement in the parentheses. So in this column, we will list P and Q. After we list P and Q, then we create another column, which is not P and Q. So let's see. T and T, choose and choose, that's choose. Choose and false, that's false. False and true, that's false. False and false, that's false. What's the opposite of the choose value in this column? That is false, true, 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 true. So this is the way we create the choose value. Let's see. First step, list the simple statements. Second step, create a column that we have the statement in the parentheses and find the choose value of this statement. Next step, create another column and put the rest of the statement in it, which is the negation of P and Q. And the choose value of this is the opposite value of this column, which is true. Choose negation is false, and true, true, true. Okay, these are 3 steps we can create the choose value, choose table. Okay, next example, use the choose table to find this. Is true or false? And they already provide us the statements true or false. The first statement P, Harvard is a college, this is true. Q is Yale is a college, this is true. If I create the choose table, so it's easier because they already gave us the value of the simple statement P, Q. P and Q, they're all true. So next step, I need to create a column, the statement inside the parentheses, which is P and Q. P and Q is true. Next column is not P and Q, is false. So the answer for this question is false. Let's move on. Let's move on to next example. Construct a choose table for not P or not Q to determine when the statement is true and when the statement is false. First, we list the simple statement on the top, show 4 possible cases for the choose value. The first step. Make the column for not P and not Q. Why? Because in this statement, you will see we have 2 parts, not P and not Q. So we need to create 2 columns for not P and not Q. So P is choose, not P is false. Choose, false, false, choose, false, choose. And for the not Q, choose, true, false, false, true, true, false, false, true. And then the last column we need to create is not P or not Q. So that means this column or this column, we find the choose value for these 2 columns. So false or false is false. False or true is true. True, false. True or false is true. True or true is true. Let's see an example. Construct a choose table for not P or Q and not Q to determine when the statement is true, when the statement is false. First, we still do the same thing, that list two simple statements and four possible cases. And the second step, what should I do? Look, I have not P here and not P or Q here. We have not Q here. We do the things inside the parentheses first. So I will start from this and this. So next column I need to create is not P, not P. Not P is the opposite of P. So choose true, false, true, false, false, true, false, true. And what's the next column? So the next column should be this. So I create another column, which is this part. It's not P or Q. Not P is here. Q is here. So even Q is in front of not P, but the relationship, this are the same. That means true or false. That is true. False or false. That's false. True or true is true. False or true is true. So what's the next column I need to create? So look at the question. I need to have this part, which is not Q. Let's create not Q column. Not Q. So that's the opposite of Q, which is false, true, false, true. And the last column I need to create is I need to list all of these in that column. So we have this, not P or Q and not Q. And this part, the first part is here. And the second part is here. Find the relationship. So true and false, that's false, because in this relationship, the conjunction relationship, there is one false, then is false. False and true, that's false. True and false, that's false. True and true is true. Okay, let's move on to see the example. Construct a truth table for P or not Q. Okay. So in this statement, we have only one simple statement, which is P. So I list the P in the truth table, and it only has two truth value, which is true, false. And then I create another column for not P, which is false, true. So find the disjunction of P and P or not Q. So add another column is P or not Q. Oh, not P, sorry, P or not P. So this is true, and this is true. It's always true. So here are the steps. So that proved things that P or not P is true in all cases. In all the cases, P or not P are always true. Okay, next example. Construct a truth table for the following statement. I study hard and ace the final, or I fail the course. So we need to read the statement by parts. I study hard. This is one statement. And ace the final, another statement. And then I failed the course, another statement. So they provide us the three statement. P, I study hard, which is here, P. Q is I ace the final, it's Q. Or I failed the course, R, P and Q, or R. And see here, there is a comma here. So there's a parentheses here. Let's see, let's create the truth table for this statement. I list the simple statement for P, Q, R. And for three simple statements, there are 8 possible cases. So you will you just memorize this, or when you solve the question, you won't met this kind of table because too many true or false value here. You will only make the two simple statements choose table. Okay, so true, true, true. For the first one, true, true, false, and then rest of them you fill the table. Okay, so from this statement, first one I need to the column I need to create is P and Q. So P is true, Q is true, the value is true, and true, 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 and false, that's false. True and false, that's false. False and true, that's false. False and true, that's false. False and false, that's false. False and false is false. And then use this column. I need to find the disjunction with R. So R is the column here. So true or true, that's true. False or true, that's true. True or false, that's true. False or false, that's false. True or false, that's true. False or false, that's false. True or false, that's true. False or false, that's false. Okay, let's move on to next part. Determine the truth value of compound statement for a specific case. Here they provide us a graph. It shows the average gasoline prices of the country from 1985 through 2010. So it starts from 1985 and 1990. So here should be 1995. 2000 2005 and 2010. Okay, let's read the question. Let P, Q, and R represent the following simple statement. Let's see what's the statement. P is prices peaked in 2005. So do you understand the graph? Look at the graph. This is the line, the price of the gasoline as the time passed by. And look at here, this is a peak. At 2000, that means the gasoline price in 2000 is approached the peak, and the price here is approximately 3.5. Okay, let's see the statement P is prices peaked in 2005. That's a false statement because it peaked at 2000. Let's see Q. Prices remained steady from 1990 through 1995, from here to here. From here to here. Is that right? Yes, because this is a straight line and the price of the gasoline is kept at 2.5. So this is a true statement. Price remained steady from 1990 through 1995. This is true statement. Let's see R. Prices were more than 3.5 per gallon in 2005. 2005, the price is here. It's not more than 3.5. It's about 3.25. So this is a false statement. I put F here. Let's see what the question is looking for. Write the symbolic statement P and Q or not R in words. The truth value is true or false. Let's see. P is the prices peaked in 2005. This one is and prices remained steady from 1990 through 1995. Or not R. Not R is price. Here R is price was more than. So not R is price or less than to $3.5 per gallon in 2005. Okay, here is the answer. Prices peaked in 2005 and the prices remained steady from 1990 through 1995, or prices were less than $3.5 per gallon in 2005. So if you want to see the truth or false of this statement, I can create a true false table. So P, Q, R, I can make longer. P is false, Q is true, R is false, because we already know the value of PQR, the truth value of PQR, so we don't need to list a lot of other informations, just list the given information. And next column, what should I do? I need to list the statement in the parentheses, which is P and Q. So false and truth, that's false. And next one, I list the not R. Not R is true because R is false. Next one, I need to list P and Q or not R. So let me make it pretty. Okay. R, this is R. So this one or this one is true. So P and Q or not R is true statement. Okay, that's about the chapter 3.3. If you have any question, please let me know. Please email me or ask me in the tutoring session. Okay, have a good one.